This video series is about comparing groups on a quantitative response variable, and there's various types of graphs and descriptive statistics that we could use when we compare groups, but I have to settle on something, so I'm going to show you some of my favorites. Graphically, I think that examining side-by-side box plots to observe group differences is about as good as you can get. It allows you to see the variation in the groups, and it allows you to see certain points on the distribution in the groups, namely the 5-number summary, which consists of the minimum, the first quartile, the median, the third quartile, and the maximum. And then when I calculate descriptive statistics, of course, I'm going to calculate the mean as the most popular index as a representation of groups, as well as the standard deviation, which shows us variability of the groups. So those are what I typically focus on, and those are what I'm going to focus on right now as we continue to look at our plain risk data, specifically looking at the perception of risk of participants that fit into one of 3 groups: individualist, hierarchicalist, or egalitarian. So let me go ahead and call up an R document here, and I've already put in a heading for graphical displays and descriptive statistics. Let's put in a code chunk, and let's begin with graphical displays. Here is a function I can use to create side-by-side box plots. It's the box plot function. My response variable, which is quantitative, is listed first. And then I'm creating that as a function of, that's what the little tilde indicates, the viewpoint or worldview of the individuals. That's my grouping variable that puts individuals in 3 different views. I'm going to specify that the limits of my y-axis are the range from 0 to 100, which is what is the scale that is allowed on checking the perception of risk of the individuals. My label for the x-axis is going to be worldview. My label for the y-axis is going to be perception of risk score. And I have a main title, although that main title, when I write a report, I will get rid of, and instead I prefer captions. But for now, we're going to keep that title in there because I'm not writing a report and I'm not creating those captions. So when we run this, here is what we get for our graph. If we want to, we can specify a wider graph. Here I have changed the figure width to be 10, and as such, I'm now getting a graph that fills up more of my page here so I can see it better. Notice that my Y limit was a good choice. If all of these boxes were all taking up, say, either the top part of the graph or just the bottom part of the graph, I would probably change these limits. Let's see what happens if I run this without those limits in place. I get pretty much the same thing here. So what I often will do is not have this Y limit command to start with and see if I get a good outcome from that. And then if I would like something a little bit different, then I put in that Y limit. In this case, it doesn't seem to make a difference. All right, let's look at these box plots and see what they tell us. First thing that I notice is in terms of the interquartile range, which is gray, I notice that there's a lot more variation in the individualist than there is in either the hierarchicalist or the egalitarian. I notice up here some outliers for the egalitarian up here at the top, but without those outliers, that the egalitarian box and, in fact, this entire spread, the what are sometimes called the whiskers as well as the box, all kind of move down below what we see with these other groups. If I'm looking at the medians, focusing on the center of the distributions, I have almost the same thing for individualist and hierarchical list, but I have lower for egalitarian. And if this was my field of study, I might have an interpretation for that. We could go back to our grid group typology that I talked about in the first video and see if it makes sense that egalitarians would have less perception of risk. In terms of the width outside of the interquartile range, they're really about the same. The range is about the same from min to max in all three of these. But the interquartile range, the inner 50%, is wider for the individualist. So this right off the bat gives me an understanding of both variation as well as center of the distribution. It is my first shot at working towards an answer to the question, and right now I say yes, that there are differences. The differences occur both in terms of spread and in terms of the center of the distribution, with egalitarian having a lower center and individualist having more spread, especially in the middle 50% of the group. Now it's time to move to descriptive statistics. So let's look at how we can do that. I'm going to create another code chunk and put in some commands for descriptive statistics here. When we are staying in base R, that is, we're not loading any additional packages, but we're staying with the descriptive statistics that are supplied to us in base R, this is probably the most common way to obtain various descriptive statistics for the groups. It's the tapply function. And the tapply function will apply another function. In the first case here on line 29, it's summary, and in the second case, it's standard deviation, or SD. It will apply that function to the score, the plain risk score, that's our quantitative response, and it will do it separately for each of the groups. So if I apply line 29, I should get the 5-number summary for each of the groups, and then line 30 will give me the standard deviation for each of the groups. And this is indeed what I get. Here's for individualist. Here is the 5-number summary. You can see up here, we talked about the wider range for the interquartile. Notice that it goes from 10 to 60, whereas down in hierarchical list, it goes from 20 to 50, and in egalitarian, it goes from 5 to 35. So that's the interquartile range. We can see here that the means, which do not appear in these box plots, the means are about 39, 37, and 25. Now, I don't know a whole lot about, I don't know anything about this scale. Not only do I not know a whole lot, I don't know anything about this scale. So I don't know if a difference here of, say, 25 to 39, which is the biggest difference, that's a difference of 14 points. I don't know what that really means in terms of perception of risk, whether that's a lot or a little. I can get a little bit of an indication of that by looking down here at the standard deviations. The standard deviations are 30.5 for individualist. That's the highest, and that's what we observed in our graph, was it had the highest variation. And then right around 24, 25 for both of the other two groups. So if I were to take, say, about 25 as a fairly representative standard deviation for three of those groups, it's not quite 25 because individualist is a little bit higher than the others, but if I took about 25, then when I'm talking about a mean difference here of 14 points, a little more than half of 25, so it's roughly a little more than half of a standard deviation. And I will tell you that in most fields in behavioral, social, and medical research, a half a standard deviation would be considered substantial. So I'm going to guess that this is quite a substantial difference in terms of risk going from egalitarian to either hierarchicalist or individualist. So what we're seeing up here in this box plot, looking at those median differences, and they're a little bit different. The exact same median, 32.5 here for individualist and hierarchicalist. A median here that's about 12 less. So about half a standard deviation again. When we're talking about a half a standard deviation, that is typically considered a pretty substantial effect, at least a moderate effect, if not moderate, large, or large effect. It again all depends upon context. So those are descriptive statistics. Now, if you look at these and say, wait a minute, that's a little sloppy for a report. How can I put the standard deviations up here with these? Well, if you're going to use these two commands, then you'll probably want to have either the standard deviations reported in the narrative and then put the other stuff in a table, or you're going to have two different tables here. But I'm often asked by students, how can I create a nicer looking table when I'm comparing groups? The best way to do it, in my opinion, is to learn a package that will do that for you. My favorite package is GT. The GT package has pretty simple commands to make very nice tables, even in the most complex of situations. But I've pretty much committed, with the exception of some libraries like the HERE library that I require use for in my courses, I pretty much commit in this course not to get into those other packages simply because I want this course to focus more on statistics than on running R, although we cannot avoid using a statistical package to do our statistics, so we have to learn some of the functions in R. But I pretty much have committed to trying to stay in base R. That said, I can show you a way in base R that we can get a better looking table. And so let me go ahead and clear this code chunk and let me put something else in instead. All right, it looks a lot more complicated, but it's really not. I'll explain in a moment, but let's go ahead and see what the output looks like. There's the output. Everything kind of comes together. You don't have to make separate tables. We could just, if I was doing a report, I could put a caption on that as a single table, and that would be fine. I think the output should look a lot nicer to you than what we had before, and I did this entirely in base R. So let me show you how I did it. What I did is I put all of my summary statistics into a data frame. If you remember, when we loaded in the plain risk data, over here in my environment, notice plain risk. When I clicked on that, I showed you how it created a spreadsheet, and that is a data frame in R. Turns out looking like a spreadsheet. Well, what I've done is created the same sort of thing. I've created a spreadsheet here in R for summary stats. And so here's the way I created that data frame or that spreadsheet. I used the data frame command, and then I put these in one variable at a time. Notice I'm still using tapply, but now I'm just doing it one statistic at a time. And what I put in the front is what I want to call that statistic. So if I wanted the entire name minimum, I could put in minimum here, but I just went ahead and put in min. And then I am using the tapply the same way I did before, but instead of coming up with all of the summary statistics at once, which would give us that unwieldy looking format, I'm only doing one statistic at a time. So for the first quantile, I'm doing tapply and putting in quantile, but I have to tell it which quantile, so I create another argument here of 0.25. Then I did median, Then I did the third quantile here, so I put in 0.75. Then I have maximum, put in max, then the mean, standard deviation. And if I wanted to change the order of these, if I wanted the mean to come right after the median, I could put it up there. So you could do any order you want. And that first bit of commands, that's actually one function, data frame, I'm storing it in summary stats. And that all comes together. So if I were to try to run this line, you'll see that there I ran it. Notice where my cursor is right on line 37 because this was just all one function. And then what I'm doing here on line 37 is I'm printing a data frame. Which data frame? The one I just created, summary stats. And then I have a few little arguments that aren't necessarily needed. Let me go ahead and take them out for now and show you what happens. If I take those arguments out, what I ended up with is a really compact, compressed table, and I have a lot of digits, more than I like. And so what these two arguments did, this one said, let's restrict it to 4 significant digits. And what this one said is, let's put a little bit of a gap between each of our variables in this data frame. And you could play with those to achieve the results that you like. So again, to summarize, you can use the t-apply. It's much shorter than what I did just here, but it doesn't give as nice of output. You can do what I did just here, in which you create a data frame, or you can learn a table. And if you were to do a web search for R tables, you'll find lots of different packages available for those. Again, my favorite is GT. All right, we've now done our basic statistics. If you note back here, I also had a third bullet in which we're going to model scores as a function of groups and analyze effects and residuals. That sounds like multiple regression. But didn't multiple regression involve a quantitative explanatory variable? Yes, in previous videos it did, but now we're going to do it with a categorical variable. And so let's take a look at how we can model scores as a function of groups, what that model tells us about the effects, or in this case, because we're not doing an experiment, it's really not effects, it's just differences. And let's look at the residuals. So to help us look at each individual in our study, not just the groups, and we'll look at the differences in means and the coefficient of determination. The coefficient of determination, you probably remember from when we did regular multiple linear regression with all quantitative data. But now we're actually going to look at effects as differences in means. So I'm going to do that in the next video.